gentlemen. So today we're going to talk about lesson 1.6, which talks about relations. So first, we have our skills that we're working on today. We're working on understanding that the graph of an equation in two variables is all the set of solutions plotted in the coordinate plane. And we're going to understand that a function from one set, called the domain, to another set, called the range, assigns to each element of the domain exactly one element of the range. We're also going to make sense of problems and persevere in solving them. And let's get started on some vocab. So for our unit on relations here, our lesson on relations, our first vocabulary term is the coordinate system. And again, this should be review, but the coordinate system is built by a horizontal number line and a vertical number line that intersect at their 0 point. That 0 point is known as the origin. It's also called the coordinate grid or the coordinate system. So that's our x and y axis. Ordered pairs. Well, we use ordered pairs to describe the location of a point in the coordinate plane or the solution of an equation in two variables. When we write our ordered pairs, we always list the x coordinate first and the y coordinate second. So every point in our coordinate grid can be described by an ordered pair. The final vocab term for this slide is mapping. Mapping is a diagram that illustrates how each element of the domain is paired with an element in the range. So if we look down at that bottom corner, we write arrows to show how each element in the domain pairs with an element in the range. So again, I have that same image popping up here. When we're talking about the domain and the range, the domain is the first set of numbers in an ordered pair or relation. So that's our x values. The range is then the second set. It's the y values. And so we will map out to show how each element in the domain matches with an element in the range. The independent variable, and in science class over the next few weeks you'll get to learn a little bit more about how independent and dependent variables look in science. But in math it's very similar. The independent variable is the variable in a function whose value is subject to choice. It's our x values. Our dependent variable is the variable in a relation whose value depends on the independent variable. When we're graphing it, these will be our y values. And these ideas are really similar to science, and you'll see with our practice problems that we're going to deal with some situations. So first, let's practice. We're going to represent a relation. We're going to represent it in three different ways. I have these four ordered pairs, and I want to represent it as a table, as a graph, and as mapping. So the first thing I want to do is I want to make my little table. You can make a table in your notes. But before I write anything in, I need to label my table. I want x and y. Let's go with red. I don't like blue. So if I'm looking at that first ordered pair, I always see my x value first and my y value second. So my first ordered pair looks like 4, -3. Same thing for the next one. I get 3, 2. Next ordered pair, -4, 1, and 0, -3. I can express this relation. So this here is my brace. I can express the relation within those braces as a table by pulling out my x values and partnering them with the appropriate y value. Then if I want to graph it, I'll do the same thing. I'll take those ordered pairs. 4, -3 tells me I go over to 4 on the x-axis and down to -3 on the y. 3, 2 over 3, +2 on the y. -4, 1 over to -4 up to a +1 on the y-axis. And 0, -3. So 0 tells me I'm at this 0 point for x, and I go down to y equals -3. So I've represented it now as a table and as a graph. Now it's time to map it. So to map it, again, I need to label this. I'm going to have my domain mapping to each element in the range. My domain looks like 4, 3, -4, 0. And my range, I have -3, 2, 1. And then I have a -3 again, but because I'm mapping it, I can leave it alone. I'm going to show that 4 partners with -3, 3 partners with 2, -4 partners with 1, and then 0 also maps to -3. So then, if I go back to my clicking now, maybe. So now, I want to know, let's put the pen away. I want to determine the domain and the range. And so the way that I would write this out is I'm going to take my domain and I'm going to use braces, which we're going to go kind of like this. And my domain are the 4 numbers I see in the domain map. Braces are hard. My range is just the 3 numbers. So if I'd written out my range and I had an extra -3 down here, I could keep it there, but when I'm writing it out as a range, I want to make sure that I'm only including the set of values. I don't want any doubled values. So if I put this here, -3, 2, and 1. So I have my domain and my range, and I've expressed this relationship or this relation in 3 different ways. So now we're going to talk about the next type of practice problems that we're going to look at. We want to identify the independent and dependent variables in each relation. So this is where your math is looking a little bit like science today. You're going to look at 2 different examples here. The first one, as the amount of rain decreases, so does the water level of the river. So the one that's subject to choice is that independent variable here, that amount of rain. That's the value that's changing. And that change is causing the water level of the river to change. The water level of the river depends on the amount of rain that it receives. It doesn't work the other way around. If I change the water level of the river, that doesn't change the amount of rain that my city or my location receives. The amount of rain changes the water level. One more example here. If Miss O'Leary is buying concert tickets for her friends, the more tickets she buys, the greater the cost. So again, this time, the more tickets that I buy, that's the one that's subject to choice. And then the effect, that dependent variable, is the cost. So if I were graphing either of these situations, the amount of rain or the number of tickets would go on that x-axis, and then I would plot the result, either the water level or the cost, on the y-axis. X values partner with independent variables, y values partner with dependent variables. So the last practice problem you don't need to include in your notes. You should have included the other ones, but these ones here, we're going to take a look at some graphs. And again, this is where your math is kind of sciencey today. First thing we want to do is we want to describe what is happening in the graph. So if I take a look at this graph here, I see an independent variable of time and a dependent variable of distance. The graph represents the distance that Francesca has ridden on her bike. Describe what happens. So what I see is I see 3 separate segments on this graph here. I see segment A, segment B, and segment C. Segment A shows me that as time is increasing, her distance is increasing. So Francesca is moving away from her starting point. Well, in segment B, her distance is not changing. So time is passing, but she is exactly as far away as she was. So that tells me that she stopped moving. Section C shows me that as time is increasing, again, her distance is increasing. So she is continuing to move along her path. So just to show you the book definition here, as time increases, the distance increases until the graph becomes a horizontal line. So time is increasing, but distance remains constant. At this section, Francesca stopped, then she continued to ride her bike. So we're just analyzing the different pieces here. One more example to look at. This graph represents the height of a bungee jumper. So what it shows me is that time, again, is my independent variable, and height is dependent. So as the time is changing, my bungee jumper was on the edge of the cliff, and then they rapidly lost a lot of distance, gained some of it back when they bounced, and again up and down, until eventually they would land on the ground. So to wrap all of this up, you have a homework task to complete. Assignment number 3 is from page 43. You're going to do 1 through 9, odd, 16, 21 through 23, 28, 30, and 37. And again, this assignment will be due on Wednesday, so tomorrow, if you're watching this video on Tuesday. This assignment is due on Wednesday by 5 p.m. And then on Wednesday, you need to make sure you have all 3 assignments, 1, 2, and 3, submitted on Teams with that form. And any additional time, you can work on the Delta Math Chapter 1 Boot Camp. This Chapter 1 Boot Camp is going to be due by Friday at midnight, so make sure that you're making progress on it tomorrow. Thanks, guys.